So today let us start our day with a problem. Okay, so let me state the problem first. So let's say you have been given an array. Okay, you have been given an integer array of size n. Okay, now the question is that you have to find number of pairs I comma j, and by the moment I see number of pairs, I mean to say number of ordered pairs. What does it mean? That if you are saying 5 comma 7 is one of the pairs, then please do not say 7 comma 5 again. Okay, so I hope you will keep this thing in your mind. So you have to find number of ordered pairs I comma j within this array such that following conditions hold. First condition should be that I must be smaller than j, and second condition should be that array of I should be strictly greater. There is not even equal, right? Should be strictly greater than array of j. So obviously I and j are nothing but they are the indices of the array. So they will be varying from 0 till n minus 1, right? So I simply have to find the number of ordered pairs for which I is smaller than j and array I is greater than array of j. So let us take an example and you try to tell me the answer for that. Let us say the input array looks somewhat like this: 5, 1, 2, 3, 0, 4. So if this is my input array and I have to find the number of pairs which obey these conditions, can you tell me what will be the answer for this case? How many ordered pairs I comma j do you see within this array that follow the given rule? Don't give me wrong answer, okay? You can take your time, but I don't want wrong answer. Now just look at the board very carefully, everyone. Just focus your attention over here. So an important thing to understand over here is, if let's say this were my array, okay, then the two indices that I am looking for, I and j, they should be such that I is smaller than j. So one thing is obvious, that the index I must be lying towards the left side of index j. Okay, index I must be lying towards the left side of index j. That is the first thing. But at the same time, the value present over here should be greater than the value present over here. Okay, so such kind of combinations I want, such kind of I comma j for which I is towards the left of j, but the value at I is strictly greater than the value at j, right? So these are the kind of combinations that I want. Okay, so we saw that there were 8 such combinations, and those combinations were, if I consider, if let's say my array I is 5, okay, then with respect to 5 I can have 1, with respect to 5 I can have 2, I can have 3, I can have 0, and I can have 4. Okay, so when I consider 5 as one of my elements, then all of them can be regarded as the second element of the pair, one by one, and all of them will be following these rules. Okay, cool. If I regard 1 as my first element, okay, then how many options do I have for second element? So I just have one option, and that is 0. Okay, so along with 1, if I consider this 0, then this rule will get obeyed. Okay, so see, the point to be kept in mind is, the moment you fix your first element, your second element has to come from the right side of it because of this rule. Okay, so never turn back. Okay, so now I fix, the moment I fix 2 as my first element, how many options do I have for my second element? I can't have 3 because it is greater, I can't have 4 because it is also greater, I can just have 0. Okay, the moment I fix 3, then also one option 0. The moment I fix 4, then also one option 0. So 5 options for this when my first element is 5, and 6, 7, sorry, hold on. For 4 you will not have anything, right? Because there is nothing towards the right side of 4. So 5 options here, 6, 7 and 8. So for this case, my output will be 8. Can you simply write a code to solve this problem? Yeah, 2 loops. So can you do it in 2 loops? Yes. Writing 2 loops, you can simply consider all the ordered pairs one by one. The most important thing is that the loop should be structured in a way that if you have considered index 2 comma 5, you should not consider index 5 comma 2 again. You should anyways not consider, because when you fix one index as your first element, second must be from I plus 1 to n minus 1. Yes. So you can simply consider all those, check those, and that way you will get your answer. That way you will get your count. But the time complexity of that would be order of n square. Okay, and this is too much. Okay, so can I do better than this? You are saying that you will create pairs, and your pair is going to be a pair of element, comma, the original index of that element, right? So from this you will create 5 comma 0, from this you will create 1 comma 1, from this you will create 2 comma 2, and so on and on, right? And then you are saying that you will sort these pairs based on magnitude, right? Let's say you do that. Let's say even if you do that, what would happen? You will get 0 with its index as 0, 1, 2, 3, 4. Then you will get 1 with index 1, 2 with index 2, 3 with index 3, 4 with index 5, and then 5 with index 0. So sorting with respect to magnitude has happened, but these things are not sorted. Indices are not sorted. So can you think of a way in which you can skip comparing, okay, first on index and then on value? But it is already sorted on index, no? I mean, this index is 0, this is 1, this is 2, and then this index is 3, 0 comma 3, and this index is 4. So it is already sorted on index. That is what I feel, right? So you would just need to sort it on value. For right now, maybe just consider that there are no duplicates, just for simplicity. I'm not sure about your complete strategy, but I feel if you just sort, let's say first based on index, it is already sorted based on index. Okay, and then let's say you sort based on magnitude, then also your problem will not be solved, because you would want to figure out the combinations that obey this thing, and I don't see how you can maybe do that in order n log n time or order n square or something like that. So think over it more, and if you feel something better, then maybe we can discuss about that. So let us all try to understand. I am not going to go into the details of merge sort. I am not going to say that concept first that one of you have written. Rather, I would ask you one simple question. In the last class, while talking about merge sort, I spoke about a paradigm called as divide and conquer. Does everyone remember that paradigm? Divide and conquer? Very good. Okay. So what does a divide and conquer do? It divides a big problem into two smaller problems, and once those two smaller problems are solved, then the larger problem is automatically solved, okay, by doing some small thing, and that thing is called as conquer part. So let me ask you a simple question. Let's say my input array was 5, 1, 2, 3, 0, and 4. Okay, so what I am going to say is, hey, I am supposed to find the inversion count. I am going to write IC as inversion count. So I am going to find the inversion count of this entire array, and the entire array can be represented as its left index and right index, which is n minus 1. Okay, so if let's say I split this array into two parts, 512, which is left part, and 304, which is right part. Okay, so can I say that the inversion count of this entire array will be the sum of inversion count of this and inversion count of this? So let's say this is from index 0 to m, and this is from index m plus 1 to n minus 1, where m was 0 plus n upon 2. So can I write something like this, that inversion count of the entire array is inversion count of its left half plus inversion count of its right half. If you are worried about inversion count, you should not be worried, because inversion count is exactly this count that I want you to find. The 8 that you got over here is the inversion count of this particular array, which was given to you as input. Okay, so yeah, that is what is inversion count. So if you are supposed to find the inversion count of the entire array, can I write that as inversion count of the left part plus inversion count of right part? Now just take your shot and tell me whether it is right to say or not. So let us just check whether this is right or not. So for this entire array, what was the inversion count? This was 8, right? And what is the inversion count for this? 2, right? And what are those? Which pairs are leading to inversion count? 5 1 and 5 2. 1 2 is not leading to that. So it is 3 over here. And what about this? What is the inversion count here? The inversion count is, I think, just 1. Okay, which is because of 3 0, right? So this is 8 and this is 4. So see, I was able to, when I said this 3, then I meant 5 1 and 5 2. I think, is this 3 or is this 2? You will have 5 1 and then you will have 5 2. You will not have 1 2. So I think it will be 2 over here and it will be 1 over there. Am I right? So this is 5 1 2, right? How many pair of inversion counts do you see over here? 5 1 and then I see 5 2 and then I see nothing else. 1 2 is not an inversion count. We were till this point where I said that, can I write that the inversion count of this entire array is the sum of inversion count of this and the inversion count of this? Can I write that? So we saw that we cannot write that. Okay, somebody is saying yes. I'm not sure why. Okay, because the inversion count of this entire array is 8. The inversion count of this is because of 5 1 and 5 2. 1 2 is not in that inversion count. So inversion count of this part is 2 and the inversion count of this part is just because of 3 0. Okay, so that is 1. This is 2 plus 1 and this is 8. So I cannot write it like that. Okay, so can somebody tell me why am I not being able to write like this? I'm just trying a simple divide and conquer. I divided my problem into 2 smaller problems and from that I am trying to find the solution to large problem. So why can't I write it like that? Anyone? Unable to compare with other half elements. That is a vague statement, but kind of makes sense. You could have written that in a better way. So not independent half problem. That makes a bit sense. So if you take a look, the inversion counts that are being considered over here are 5 1 and 5 2, which is this and this. And the inversion count which is being considered over here is just 3 0 and others are simply not being considered. Now let us understand why they are not being considered. They are not being considered because it might so happen that an inversion count is being incremented because of 1 and 0, where one element is from left array and the other is from right array. It can also happen when it is due to 5 and 3. It can also happen due to 5 and 4. So this is intra-array inversion count. So this is the inversion count within this array. This is the inversion count within this array. But how about inter-array inversion count? Inter-array inversion count means the inversion count which is being incremented because of one element lying in one array and the other element lying in another array. So such pairs will end up getting excluded. So this is the fundamental step in getting this problem. Okay. So if I have to add something over here, if I add something over here, then my job will get done. Can somebody tell me what should I add over here? Conceptually what should I add over here? So I should say that I need to consider inter-array inversion count. I'm going to write it like this: inter-array inversion count, that means across the arrays, okay, in which my first array is from 0 to m and second array is from m plus 1 to n minus 1, okay. So if I have to find the inversion count in entire array, that can be found out by finding this and finding this, okay. So let's say you are somehow able to find the inversion count within this array magically. Let's say you found it out. Similarly, you are able to find out the inversion count in this array also magically. Let's say you found that out, right? Now the turn comes to find this. See, I am asking you to hypothetically assume that you somehow found this out, okay? Now I want you to focus your energy on trying to find this thing out, which is the inter-array inversion count across the two arrays, okay? So see, my first array is 512 and second array is 304. If I ask you to find the inter-array inversion count, the size of this is n by 2 and the size of this is n by 2. Can you tell me how much time will it take for you? Let's start with brute force. In how much brute force time can you find the inversion count across the two arrays? Somebody wrote n. and I want you to explain why do you feel it should be n. So n square, guys, can I do it in n square or not? I wanted to hear brute force approach first, and if that is not coming, that means you are missing out the key interview tactics. The first thing that any person would like to hear from you is the most intuitive approach, okay, and you are not even speaking that, so that is a red flag, okay. So what will you do if I have to find the inter-array inversion count? What I can do is I can pick an element over here, and for this element I'll traverse this entire array and check that how many elements in this are strictly smaller than this. The same thing will be done for this. The same thing will be done for this. So for every element in this array, I'll be making n by 2 traversals in the second array. So how much time will this approach take, by the way? So there are n by 2 iterations that are happening, okay, for each of the element in left array. So can somebody write the time complexity? It will be n by 2 into n by 2, which is n square by 4, which roughly is order of n square only. Okay, so this is not so good, right? Because I am doing order n square iterations. So can I somehow make this a bit better? Somebody talked about merge process. How can merge process help over here? So let's not even talk that. That is a different thing. Okay, if you have heard that merge process works, that's a different thing. Let me ask you a different question, and now listen to it very carefully. Okay, I'm asking you that, hey, let's say you are trying to find this thing, which is inter-array inversion count. Okay, now I permute the elements over here. That is, I create a random permutation of this. Okay, and I create a random permutation of this also. Will this thing be impacted? How will that be impacted? Let us take an example. Let's say you permute it into 152 and you permute it into 430. How is that going to get impacted? If you have a 5, if you had a 5, 0 before, you still will have a 5, 0. If you had a 2, 0 before, you still will have 2, 0. If you had a 5, 4 before, you still will have 5, 4. So will it really get impacted? It will not get impacted. Did you get this point? This is the most important point. So if there are two arrays that you have, let me call them A1 and A2. Okay, and if you are supposed to find the inter-array inversion count across A1 and A2, then that inter-array inversion count, see, I am not even touching these two things. Okay, inter-array inversion count will not get impacted even if this is jumbled and this is jumbled. Okay, so this is an important point worth remembering every time. This will help you in many problems. Okay, not just this problem. Okay, so inter-array inversion count will not get impacted. Now my question is, can you think of a special kind of permutation such that the process of calculating this thing becomes very easy? So how many of you feel that the sorted permutations of both of them will make my life easy in computing inter-array inversion count? How many of you feel like that? And that is perfectly right. Yeah, sort and then use merge procedure. Cool. So let's say I sort them. Okay, so after sorting them, you will get, let's say this is somehow magically sorted, so it will become 1, 2, 5, and let's say this is also somehow magically sorted. Okay, 0, 3, 4. See, don't worry about the time taken in sorting them, because you might think that hey, sorting them will also take n log n time. For now, just relax and think that they have been magically sorted. Okay, so let's say this is sorted and this is sorted. Now can I find the inversion count in a very optimal way, in very less time? Okay, so let us now look. Okay, because now begins the most important thing. So let's say the left array contains few elements and it had 6, 7, 9, that's it. And let's say the right side array, it contains elements like 8, 10 and others. Okay, so what would happen is that at some point of time when your index j is here and index I is here, so remember this is also sorted and this is also sorted, okay, and you are trying to merge these two sorted arrays. So if at any point of time your index j is here and index I is here, okay, so at this point of time, which element will you push into the merged array? Which element will you push? Okay, so I hear that, but can you tell me at this point of time which element will be pushed into the temporary array which you are using for merging? Ith element, right? Because that happens to be the smaller element, right? And that makes sense. That makes perfect sense. But let's think of a case like this, where this was 8 and this was 17. At this point of time, where this is 8 and this is 17, which element will be pushed? Jth element will be pushed, which is 8. Okay, everyone is in sync till here, guys? Yes, no? Is everyone in sync till here? I'm asking to others. Okay, yeah. So 8 will be the element that will get pushed. Now tell me one thing. If 8 is something that you would, let's say, push into your temporary array which you are using to merge, then can I say that just because this element was greater than this, all these elements will also be greater than this, because both the arrays are sorted? So I was till this point of time that in such a kind of situation where your j is here and I is here, and you find that array j is smaller than array I, then you push array j into the temporary array, right? Okay, count plus plus is not the right thing to do, okay? So you should maybe try doing something else, and let us understand what we should try doing. So at this point of time, when you saw that this element was smaller than this element, that implies that this element will be smaller than all these elements actually from here till the end of the first array. I can say that. And why I can say that? Because that both the two arrays are what? Sorted in nature. Okay. So the moment this situation happened, I can say that, hey, if this element is to be considered as second element, then the number of options for first element is everything from here till here. So if 8 is to be considered as the second part of that inversion count pair, then the number of options for first thing is, if let's say the last index of this is even and this was I, then the number of options is even minus I plus 1. So I can say that, hey, corresponding to this 8, my inversion count must be incremented by this much step. It should be incremented by even minus I plus 1. And now you do not need to worry about the fact that, hey, did I miss out some more possibilities over here? Tell me, is it possible that you would have missed out some more possibilities over here? Okay, so what I just said was, the moment it happened that the element over here is smaller than element over here, it means that it will be smaller than all the elements here. And how many elements are over here? If this index is I and the last index is even, then the number of elements will be even minus I plus 1. So I can say that the number of inversion count pairs with 8 as their second element will be this. So I'll increment my count by this much. Did you get it now? Right? Yeah. So next thing I said that, did I miss out on some of the elements which could also potentially have been an element over here? The answer is no, because the moment such kind of situation happened where a of j happened to be smaller than a of I, then this a of I will be the first element in this array such that it is greater than a of j. Because you tell me, can it ever happen that an element that was, let's say, greater than this, an element that was greater than this 8 lied towards the left side of it? Can it ever happen that I had something like 16 over here? It cannot happen. Why it cannot happen? Because at any point of time in your merge process, I and j are positioned in such a way that they are pointing to next greater element, right? So if let's say this element was present, then the situation would have been something like this, that I would definitely have been pointing over here, okay? Because The thing is simple. What is simple? This 16 could not have been pushed into this without pushing this. Okay, so the moment this situation happens for the first time, let's say it happened over here, then I can say that, hey, everything in the left is strictly smaller than or equal to 8. Okay, and everything from here to here are strictly greater than 8. So corresponding to this, the count of inversion should be incremented by this much. Right? So now I'll push this, and now I'm done with all the possibilities for this. So now I'll migrate to the next element over here. Okay, so can you figure out the inversion count while performing the merge process? Right? You can do that. Okay, correct. So now, if let's say you are trying to do that, let's talk about few more nuances of that. So while you are doing merge process, and when your main for loop is over, what happens? One of the arrays is still not over. Does it happen or not? Yes, no. It happens, right? So let us consider about those scenarios also. So see, while writing your actual merge process code where you are comparing AJ with AI, you can keep on incrementing count by this much and everything looks good and you're fine. But think of it in this way, that certain elements remained in second array. So array 1 was over. But in array 2, let's say certain elements remained, 10, 15, 19. These many elements remained. So what would you do? What would you do for those elements? Would those elements ever contribute to inversion count? Tell me. Inter-array inversion count? Never. Why? Because the reason they remain is because they are greater than everything from here to here. Yeah, the reason they remained is because they are greater than, all of them are greater than everything from here to here. So they would never contribute to any extra increment in inversion count. So I need not do anything about them. So this case is being taken care of where certain elements of array 2 is over. Okay. Now let's consider the second case where certain elements of array 1 is over. So let's say certain elements of array 1 which are, not over, they are left. So certain elements of array 1 which are left are 16 and 20, let's say, and array 2 is completely over. In this case, what should I do? What should I do over here where certain elements of my array 1 is over? So here also I should do nothing. Is that clear to all? Yes, no. Why should I not do anything? Because the reason it happened is because what would have ideally happened? Let's say you had an element 7 over here and an element 11 over here. Okay, so let's say when 7 was over here, you had an element called 10 over here, and then you had 6 over here. So corresponding to this 7, you would have incremented your inversion count by 3 units, and corresponding to this 11 also, so let us consider this was 12, and corresponding to this 11 also, you would have incremented your inversion count by 3 units. So this array getting over means what? That you have considered the inversion count of all the elements. Okay, so even if this is over, then I need not do anything for those elements because their contributions have already got counted. Cool. So in order n time, you can figure out the inversion count across 2 sorted arrays, right? In order n time. Basically inter-array inversion count, correct? And how much time is this everything gonna take? If let's say the 2 arrays were sorted magically and now you are trying to find the inter-array inversion count, how much time would this have taken? If the size of the 2 arrays are n by 2 and n by 2, it would simply have been equal to the time complexity of what? Merge process, which is order m plus n, which in this case will be order n. So finding out this thing is very easy, but how about these 2 things? So I can find this in order n time, but how about these 2, which is intra-array inversion count within the same array? How can I find them? Come on, tell me. Recurse. Okay, you again simply, the way you broke this thing into 3 pieces, you can break this thing also into 3 pieces. Did you get my point? Yes, no. If you have to find intra-array inversion count within a subarray, you break that subarray into 2 parts, and when those 2 are sorted, then you find the inter-array inversion count in that. Can it be done while running the code of merge sort only? It can very easily be, because now just think of it in this way, that merge sort is running as it uses to run, okay? And let's say you had 8, 7, 6, 5, 4, 3, 2 and 1. You called merge sort on 8, 7, 6, 5. You called merge sort on 4, 3, 2, 1. And now you perform merge process over here. While performing merge process, you can find the intra-array inversion count for this and this, because by the time this would have returned and this would have returned, this portion would have got sorted and this portion would also have got sorted. And now you can very easily compare and find the inter-array inversion count of 5, 6, 7, 8 and 1, 2, 3, 4, because they have got sorted, okay? And then you can merge them. Same thing would have happened at every layer. So just think about this layer. So what would have happened? This would have broken this down into 8, 7 and 6, 5. And when both of them would have returned, then it would have done merge process where it would have found out the inter-array inversion count. Now for 8, 7, again it would have broken into 8, into 7, and finally in merge process it would find inter-array inversion count. What would happen over here? So can you tell me what is the inversion count of an array that just has one element, which is from 0 to 0? What is the inversion count of such kind of array? So it will have 0 inversion count. This, where you have called from index 1 to 1, this will also have 0 inversion count. And now while merging them, you will find the inter-array inversion count. That inter-array inversion count will be 1 plus 1. While merging them, you will see it will be plus 1. Okay, and now actually what you have done is you have found out the inversion count of this entire thing, which was 1. Okay, the same thing would have happened over here, just for 6 and just for 5, 0. But in the merge process, inter-array inversion count would have detected as 1. Okay, so now if you take a look at this, the inter-array inversion count for 8, 7 is 1, and for this also it is 1, and now it would perform the merge process where it will find the what? Inter-array inversion count. So this is like 7, 8 and this is like 5, 6. So it would find that out to be 4. So 4 plus 1 plus 1, which is 6, and 6 was the actual inversion count of this array. So this is how it is happening. So it's getting calculated from bottom to top. Okay, nothing so special about it. Okay, now how do you keep track of these counts? So somebody had asked me a question. So you can either pass a count variable which is passed by reference, or you can have a global count which is 0. Initially it is 0, and the moment you figure out an inversion count, then you increment this thing in this particular variable. So by the time your logic would have got over, your code would have got over, count would simply have contained the actual inversion count. Let's say we have an array and we have to find for every element the number of elements on the right side greater than the number of elements on the right side greater than current element. Can we do it with this approach also? I think you mean smaller. We can do, but I think what you mean is smaller, number of elements smaller than a particular element. Okay, so this is simple merge sort code only with just one line change. And what is that one line change? While performing merge of two sorted arrays, okay, you figure out the inter-array inversion count in them. Okay, now one thing that we would understand is why is this approach working and why no problem is happening is because in the last class I had spoken one thing. The moment you call merge sort for this part and the moment you call merge sort for this part, this will get permuted to 5, 6, 7, 8. This will get permuted to 1, 2, 3, 4. But an important thing is that it would never happen that an element from here comes here or an element from here comes to here. Do you remember this point? I had spoken this, right? That is the reason why inter-array inversion count is being calculated correctly. If such kind of jumbling would have happened, then it would have been problematic to me. So cool, now you can utilize this concept and you can get your job done. Now this inversion count, can you tell me if an array is of size n, what can be the maximum value of inversion count? Can you tell me for which kind of array inversion count will have highest value? When it is in strictly descending order. How many of you are able to make sense out of this thing? Yeah, because if it is sorted in strictly descending order, let's say this was the case, 8, 7, 6, 5, 4, then for first element, all these elements are contributing to inversion. So for first element, n minus 1 inversions. For second element, n minus 2. So until for this second last element 1 and for this 0. So sum from 1 to n minus 1 is n into n minus 1 by 2. Okay, and if the array is, let's say, sorted in ascending order or non-decreasing order, in that case what will be the inversion count? It will be 0, right? It will be 0. Okay, so inversion count is also the extent to which what? Extent to which my array is sorted. So if an array is highly unsorted, then it has a high inversion count, and if an array is kind of sorted to some extent, then it will have a very low inversion count. Okay,